Hello everyone. I want to welcome you this morning to another section of this tutorial. This tutorial is marking the fifth tutorial of this engineering education, Josiah Engineering Education. And today we'll be looking at engineering mathematics. So that is the section we'll be considering today, engineering mathematics. And the topic we are considering today is calculus. This topic called calculus is one of the topics that most students see as a challenging topic in engineering. And I want us to know that is the foundation of other mathematics that we have in engineering mathematics, be it Laplace transform, Fourier transform, power series, and every other advanced mathematics that we have. So once you have a solid foundation of calculus, then other one becomes very, very simple to you. Now, when you look at calculus, it's a branch of mathematics that underpins many of the equations that describes the physics, the mechanics, and the engineering. And calculus is also the study of how things are changing. So we have two types of calculus. We have differential calculus, otherwise known as differentiation, and the other one is called the integral calculus, otherwise known as integration. In this tutorial, we'll be looking at step-by-step approach to solving engineering problem that is related to differentiation. I just want us to look at this. Let's take a look at what we have here. Uh, in this graph, we have a linear graph here now. And if you look at the diagram I have here, we have 2 points, point A and point B. This graph was established by joining these 2 points together like this, giving us this point to be x2, y2, and this place to be x1, y1. And if you look at that, if I draw this line this way and I draw this line this way, it means I can determine the slope or the gradients of this particular line. So to do that, my gradient will be equals to y1 minus y2 divided by x1 minus x2. So you get your gradient by using this formula to achieve that. Okay, now when we are now looking at the differentiation, the differential calculus, it has to do with the rate of change. This one is change in y over what? Change in s. So the rate of change of one quantity with respect to the other, that is differentiation. Now, there are a couple of information that we need to understand about this differentiation. If you have y equals to s raised to a particular power, I don't know the power now, but raised to a particular power, let's call that power, let's say n now, and you are to differentiate this particular equation, y is equals to s raised to the power, which you don't know, let's call the power n now. For you to differentiate this equation, all you need to do is that will give you dy ds, which is equals to this your power, you will bring it down to this side, then you write the equation again, s power minus 1. Again, this is what we have, y equals s with a given power, which we don't know. Then the rate of change of y with respect to s, which is the differentiation of this function now, will be dy over ds equals your power, you bring it here. Your x, again, you have it here, then power minus 1. Now, let's take a look at a couple of examples that we have in this slide. Now, in this slide, we have that y equals s to the power of 2. Y equals s to the power of 2. For us to differentiate this, to find our dy ds, to find dy ds, the rate of change of y with respect to s. The power, which is 2, you will bring it down here. This is my 2 now. Then let's repeat this one. I have s squared. Then subtract 1 from the power, minus 1. So that will give you this, your 2, you have it back here now. This is your s, you have it back here now. Then 2 minus 1, that will give you 1. Then here we have 2 back here. Any number raised to the power of 1 is that number by itself, meaning that s to the power of 1 is equals to s. So by differentiating y equals to s squared, now you have the value to be 2s. Now let's take a look at this other example. In this example, we have y equals s to the power of 8. This 8, you bring it down here. Repeat this one again. S raised to the power of 8, s raised to the power of 8. Subtract 1 from it. Then this 8, it will come down here again. 8 minus 1, that is 7, giving you s to the power of 7, which is what we have here now. So meaning that if you differentiate y equals x to the power of 8, you will get your y to be equals to 8s to the power of 7. That is what the answer will be. Now let's take a look at some other problem, and let's see how we can also solve further problem on differentiation. Remember, y is equals to number s raised to the power of s, and we have what, power here. Then your dy dx is equals to number times power s power minus 1. What is that talking about? That is talking about in a situation whereby you have a number before this your x. Then in that situation, how do we approach it? The first thing you need to write is to first of all write that number. Now let's take a look at the question now. Y is equals to y equals 3s squared. Now y equals 3s squared. Now to find the y ds, first of all you need to write this 3. I have my 3 here. Multiply by the power, which is 2. Everything is now in a bracket. Now let's now come to this other side now. At this other side, you will now have x2 minus 1. So 3 multiplied by 2, that will give you 6. 2 minus 1, that is 1. So you have s to the power of 1. 6, you have it here. S raised to the power of 1. Any number raised to the power of 1 is that number. Therefore, s to the power of 1 is s. Meaning that if you differentiate y is equals to 3s squared, you will get you get your dy ds to be equals to 6x. Now, let's take a look at this. Another example. Y equals 10x raised to the power of 5. Y equals 10x to the power of 5. Now, to differentiate this now, your dy ds, remember the number first, 10, multiplied by that power, which is 5. Everything in the bracket now. Then repeat s raised to the power of 5. S raised to the power of 5. Subtract 1 from it. And that will give you 10 multiplied by 5. That is 50. 5 minus 1, that is 4. So you have s raised to the power of 4. So s raised to the power of 4. Meaning that if you differentiate y equals 10s raised to the power of 5, you will get your dy ds to be equals to 50s to the power of 4. I want to believe that is clear.